I'm told that f of theta is equal to 4 cos squared theta minus 3 sine squared theta. And I need to show that that's equal to a half plus 7 over 2 cos 2 theta. So basically I need to turn these cos squared and sine squareds into a cos 2 theta. So first let's remind ourselves of the cos double angle formula. Cos 2 theta is either 2 cos squared theta minus 1, which means that I could rewrite this with cos squared as the subject. So if I add 1 to both sides, I get 2 cos squared theta like this, and then I can divide both sides by 2 to get cos squared as the subject. So that's how I can rewrite cos squared with the cos double angle formula. We also know that cos 2 theta also equals 1 minus 2 sine squared theta. So if I do the same thing in making sine squared the subject, so I'm going to move the sine squared to the left-hand side, and I'll move the cos 2 theta to the right-hand side, and then divide both sides by 2. So there we go. Now, I'm going to now use that to help me to answer the question, because I can now say that f of theta is 4 cos squared, so that's 4 lots of the cos 2 theta plus 1 divided by 2, minus 3 lots of the sine squared, so 3 lots of the 1 minus cos 2 theta over 2. If I now expand those brackets, so I will get 4 times cos 2 theta plus 1 over 2, so that's going to be the same as 2 cos 2 theta plus 2. Because basically what's happened there, the 2's cancel out, and then I just times through by 2. Then I've got the minus 3 times 1 over 2. And then I've got the minus 3 times the minus cos 2 theta, so that's going to be a plus 3 cos 2 theta over 2. And if I now collect up the like terms, I've got the 2 minus 3 over 2, which is a half. And then I've got the 2 cos 2 theta plus 3 over 2 cos 2 theta, which is 7 over 2 cos 2 theta. So that is part A of this question done. Let's look at part B. Hence, so using the result that we just found, find the exact value of the integral from 0 to pi over 2 of theta multiplied by f of theta. And in part A, I showed that f of theta was this. So I'm going to put that here. So the integral that I'm trying to do here is the integral from 0 to pi over 2 of theta multiplied by a half plus 7 over 2 cos 2 theta d theta. Right, let me expand those brackets. So theta times a half is a half theta. Theta times 7 over 2 cos 2 theta is 7 over 2 theta cos 2 theta. Right, let's try and integrate this then. We're integrating with respect to theta. Well, the half theta, that's going to integrate easily. That's just going to be a quarter theta squared. So that's pretty easy. Now, this second one's going to be a bit more awkward to do. 7 over 2 theta cos 2 theta. Right, now this is a product of two functions. So I'm going to use integration by parts to do this. So just on the side up here, let's find out what the integral of theta times cos 2 theta d theta is. I'll work out what it is, and then I'll times by the 7/2 afterwards. So let's use integration by parts. I'm going to say u can be theta. V dash is going to be my cos 2 theta. So when I differentiate theta with respect to theta, I get 1. And then when I integrate my cos 2 theta, well, cos integrates to be sine, and then I have to remember to divide by 2 by the reverse chain rule. So applying the integration by parts formula, I have u times v minus the integral of u dash times v. Now, just to make my life a little bit easier, I can take that half outside the integral. And now let's finish that integration off, because I know that sine will integrate to be minus cos. And again, I need to remember to divide by minus 2 because of, by 2 because of the reverse chain rule, because of the 2 on the inside of the sine. And we can see that that is going to simplify to be a plus 1/4 cos 2 theta. Right, I can now take the answer to that integral and put it in here. Let me just rub that line out. Right, we've finished all our integration. Now I just want to simplify this and then substitute my limits in. So let's multiply through by the 7/2. So 7/2 times 1/2 is 7/4 theta sine 2 theta, plus 7/2 times 1/4 is 7/8 cos 2 theta. Right, let's substitute the pi/2 in first of all then. So we'll get 1/4 times pi/2 all squared, plus 7/4 times pi/2 times sine of 2 times pi/2, which is pi, plus 7/8 times cos of 2 times pi/2 is pi. So that's me substituting the pi/2 in. Now I'll substitute the 0 in. So 1/4 times 0 squared will be 0. 7/4 times 0 will be 0. And 7/8 times cos 0. Now cos 0 is 1, so I need to include that. Right, let's go through this then. So 1/4 times pi/2 squared. Well, pi/2 squared is going to be pi squared over 4. When I do 1/4 of that, I'll get pi squared over 16. Sine pi is 0, so I don't need to worry about that middle term. Cos pi is minus 1. So 7/8 times minus 1 will be minus 7/8. And then cos 0 is 1. So then I'm going to subtract another 7/8. So my final answer then, in exact form, is pi squared over 16 minus 14 over 8. And there we go, I will leave my answer like that, I think.